Hello, my name is Nohanis Fahana binti Muhammad Syafuddin, CD 210174. So today I will present about my part, which is introduction, problem statement, objective, scope and conclusion. Okay, for introduction, efficient production methods are critical to the success of the bakery, especially given the rising demand for bakery goods. To meet customer expectation and maintain profitability, bakeries must optimize their operation. Line balancing, a methodical approach in production management, involves assigning tasks across workstation in a way that ensure operators have equal workloads and maximize throughput. By strategical distributing tasks, line balancing minimize delay, increasing output and reduce idle time. In the bakery sector, line balancing focus on analyzing and improving the sequence and allocation of responsibilities within the production line. The objective is to enhance overall efficiency, eliminate bottleneck and ensure that each stage of production operates at its highest capacity possible. In today's competitive business environment, optimizing production processes is crucial for industry success. According to King Hua, addressing the assembly line balancing problem in scenarios involving regular production and preventive maintenance is essential to minimizing cycle time and adapting to operational change. The bakery industry, like any others, constantly seek ways to improve efficiency and productivity. This study focused on exploring the line balancing process within the production line of Gardenia Bakeries KL Sdn Bhd. Through observation and study, two issues, which is low production efficiency and output, have been identified at Gardenia Bakery KL Sdn Bhd, which can be improved. Low productivity directly impact a bakery profitability by hindering its ability to meet demand, leading to lost sale opportunities and potential customer dissatisfaction. Inefficient production may also increase costs, further impacting profitability. Okay, next is the Gardenia production line is currently plagued by low efficiency and output, significantly impacting profitability. This issue has led to a situation where production falls short demand, causing lost sale opportunities and potential alienating customer. To tackle this challenge, a comprehensive study is underway to address the assembly line balancing problem. The primary objective is to minimize cycle time by optimizing the allocation of tasks across the assembly line. By doing so, the aim is to enhance overall efficiency and output level. This strategic initiative is crucial for Gardenia to not only meet current demand more effectively but also to position itself for sustainability growth in the competitive market landscape. Next is scope. The project centers on optimizing operation within the plate baking industry with a specific emphasis on enhancing the production of fluffy bun. It encompasses the analysis and improving the manufacturing process within the facilities involved. However, it includes consideration related to the transportation and storage of raw materials. A key aspect of the project involves meticulous attention to the idle time at each workstation, ensuring that they are minimized to maximize overall efficiency and productivity. This focused approach aims to streamline operation, reduce cycle time, and ultimately elevate output level of the fluffy bun production line.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hashimah binti Hisham. My matrix number CD21008. Today I would like to present literature review for this topic. First, line balancing is an essential method used in the bakery sector that aims to maximize production efficiency by distributing the evenly among workstation to reduce idle time and bottlenecks. For example, the RPW approach dramatically decreased bottlenecks and enhanced output in a big baking plant per a research by Kilbridge and Western 1961. Second, manager can simulate bakery operation and test various line configuration using discrete event simulation (DES) without affecting actual production. This gives manager important insight into how maintenance schedule and equipment failure affect line performance. Notwithstanding this development, it is still difficult to adapt line balancing strategies to often alter production runs, and the growing focus on sustainability, developing more flexible technique and incorporating digital technology to optimize bakery manufacturing lines in real time should be the main goal of future research. Previous research on the line balancing strategies for the bakery sector have mostly concentrated on streamlining production procedure to increase productivity and lower overhead, to locate and reduce production line bottleneck. A number of studies have used simulation models, lean manufacturing concept, and time and motion studies. For example, the production line of a bakery was analyzed using time and motion studies, and a balanced line design was suggested that greatly increased throughput and decreased idle time. Thank you.
Assalamualaikum, my name is Nurul Ala binti Muhammad Jazmi. My camp entry number is CD 200127. Today I will like to present my part, which is methodology. In this methodology, we discuss about the method that we use in this project. One method of engineering concept that our group choose is line balancing method. This method is suitable to increase the efficiency and productivity of the bakery and decrease the operation cost, which is aligned with our objective by using several calculation and step. Flowchart shows that the step of line balancing method. First, we collect data about the production process. Next, we go to make a producer diagram to show the link between item. Next, calculate the workstation cycle time. Next, we go to calculate the theoretical minimum number of workstation. Next, we go to calculate the line efficiency and create the assembly line balancing table. The last one, we calculate the idle time. Next, we go to the formula. The first one that we have to calculate is desired output, is R. R equal to demand output rate divided by plant's output. The second one that we have to calculate is workstation cycle time. C equal to 1 per R. Next, we have to calculate theoretical minimum number of workstation. DM equal to total time divided by C. The next one we have to calculate is line efficiency. Line efficiency equal to total time divided by TM multiplied by C and multiplied by 100. The next one we have to calculate balance delay. Balance delay is equal 100 minus line efficiency. Then the last one we have to calculate is idle time. Idle time equal to TM multiplied by C and minus total time.
Assalamualaikum and hi. My name is Muhammad Nur Rahim bin Azali, limited number CD20230. I will present about the result and analysis. The bakery company station and working components are focused on plant produce are shown in table 4.1. As we can see in table 4.1 is workstation and description of the bakery company. If we want to produce a bun, we should undergoing a process like in the table. For example is dough dispenser, forming, icing chamber, turning and so on. So as you can see, in every process have their time, and for the long time taken in the process is cooling spiral and freezing spiral, which is 4,150 seconds, while for the short time taken for the process is dough dispenser, which is 6 seconds. Precedence diagram shows the independence and order of workstation in a production process. The precedence diagram below, which include every workstation on the manufacturing line. As you can see in figure 4.1, every precedence have their time, which is precedence 1 is 6 seconds, precedence 2 is 32 seconds, precedence 3 have 9 seconds, precedence 4 is 3,600 seconds, for the precedence 5 is 7 seconds, and so on until precedence 14 is 8 seconds. The task must be distributed among workstations in a way that reduces idle time and guarantees effective productivity in order to carry out line balancing for the production line. Equitable labor distribution among workstations is the goal. The monthly demand for classic bun production is 4,300 units and the total working time required is 864,000 seconds. We use a formula C equal to 1 over R, where C is cycle time and R is desired output rate. For R, desired output rate equal to demand over working time. For the demand, we have 4,300 units and the working time we have 864,000, and we get 4.98 times 10 power of negative 3, and for C cycle time 1 over 4.98 times 10 power of negative 3, and we get 201 seconds per unit, with a monthly demand of 4,300 units and an overall working time of 864,000 seconds. The cycle time for each unit is therefore roughly is 201 seconds per unit. The TM stands for the bare minimum of workstation required to reach the target production rate. It is feasible to assess the production process effectiveness and pinpoint areas that might use improvement by computing the TM. For the first, we should search for the T total and we will get 911 seconds. For the TM, we use formula total T over C total T is 911 and C is 201, and we will get Tm equal to 4.53 and Tm equivalent to 5 station. To measure the performance line efficiency, balance delay and total idle time must be calculated. Line efficiency equal to total of T over Tm times C times 100, and we will get 90.65% for the balance delay equal to 100,000 minus line efficiency, and we will get 9.35%. Idle time equal to Tm times C minus total of T, and we get 94. Line balancing calculation do not take into account non-manual activity with 5 workstation. The line efficiency for producing one is 90.65% and the balancing delay is 9.35%.
Assalamualaikum, my name is Nordin Izzati, CD210329. For this slide, I'll be discussing about this topic, which is the terms of efficiency is found to be 90.65% with a balance delay of 9.35%. The pump produced utilized only 5 workstations, which shows that there is a little idle time and maximum resource usage on the production line. This indicates on a high level of efficiency. The balance day is a measure of the amount of time workstations are not actively involved in production in a low number of workload. It's distributed fairly, and the efficient distribution of duties across the workstation are indicated by the high line efficiency and minimal balance delay, and ensure a smooth production flow. This research also shows how many workstations are theoretically needed to achieve by specific output rate. There are 5 workstations instead of 14 when non-manual process like the freezing spiral, cooling spiral, and rising chamber workstation are taken out. This exclusion creates a more functional and effective production line by increasing space utilized and lower the equipment expenses. Its potential for improvement as seen by the findings and statistically that have been provided. Firstly, it's imperative to keep an eye on line efficiency and balance delay continuously. Its frequently analysis and assessment will assist in identifying any trends or potential improvement. By regularly keeping an eye on this indicator, the production line can maintain its effectiveness over time and make the necessary adjustment on schedule. Second, by carefully examining the tasks carried out at every workstation, the potential bottleneck or areas that could benefit from improvement can be found. It's feasible to simplify procedures, shorten work times, and remove any pointless phases by looking at the process. Thirdly, it's imperative to make investment into personal training. It offers some members the opportunity for skill development and can improve their competence and productivity. Employees will be better to complete tasks, reduce error, and guarantee a smooth workflow if they develop their skills. The data and findings highlight the importance of line balancing in achieving efficient plant production. The total working time and workstation details can all be taken into account to optimize production and minimize the idle time. A more efficient and cost-effective production line can be achieved by excluding non-manual tasks and workstation. Additionally, analysis of line efficiency and related metrics will enable more focused improvement. So conclusion is terjadinya improper analysis identify low productivity and production in their bakery. This issue directly affect the bakery's profitability and ability to meet client demand. The analysis highlight the importance of solving this obstacle to improve operational performance and sustain success. The study discovered opportunities to improve the manufacturing line by analyzing the time required for each process. Understanding job duration help bakeries identify bottleneck and inefficiencies, allowing for target process modification. This information will help the bakery develop measures for equitable workload distribution, eliminating bottleneck and improving synchronization across workstation.